Assalamu alaikum wa rahmatullahi wa barakatuhu. Alhamdulillah, assalatu wassalamu ala rasulillah. Yesterday we discussed Coulomb's law, which was a law which governed the forces between two charges or point charges. Today we want to discuss electric field. Let us recap what we know. If there are 2 point charges, say Q1 and Q2, and these charges are at a distance r from the centers of each other, then force between them is given by 1 upon 4 pi epsilon naught Q1 Q2 by r square. This is the magnitude of the force, but as we know, force is a vector quantity. So if we want to show it in vector form, then we'll have to give its direction, and this force is variable for different charges. We want to generalize the concept of force, so we can fix a charge, in this case Q1, and this Q1 charge, if we call it a source charge, then what does it mean? It means that this charge is fixed, this charge cannot move. And another charge Q2, and we call it a test charge. What does it mean? It means that in comparison of Q1, Q2 is very small. This is one thing. And the other thing, that movement of Q2 surrounding or in around the charge Q1 does not affect the charge Q1. If these assumptions are considered, then we can call Q1 a source charge and Q2 a test charge. Why do we need this? Because we want to study electric field. Electric field. Let us discuss electric field. What is an electric field? Suppose there is a charge Q, and this charge is a positive charge, and we name this charge as Q source. It means it is our source charge and it has been fixed in its place, that is, it cannot move. So around this charge there will be a region. In this region, if another charge Q, call it Q test, that is test charge, if this charge is outside of this region, then this charge does not feel any kind of force, whether be force of attraction or repulsion. But when this charge is moved in this region, then what happens? This Q charge starts to feel the force of attraction or repulsion. Suppose this charge to be positive and this charge also to be positive. Then when this charge is here, what happens? This charge gets repelled from this source charge, but outside of this region there is nothing. So in visualization we can define a region around a source charge. In that region another charge, we call it a test charge, and we must remember a difference between source charge and test charge. Source charge is a fixed charge and it is quite larger in comparison of test charge, and test charge is a movable charge, that is, it can move from one place to another place. So the region around a source charge, inside of which another charge, that is test charge, can feel force of attraction or repulsion, is called electric field. That is, electric field is a region. Electric field is a region around a source charge. And of course, this force of attraction or repulsion depends on the nature of two charges, as we have already considered the source charge to be positive and the test charge to be positive. Then when this charge comes inside this region, then it will experience a repulsion. But if this charge be negative or another test charge be of negative sign and it comes inside this region, then it will be attracted to the source charge. Now we want to have a mathematical description of this field, and for this we will have to revisit Coulomb's law. And we know that Coulomb's force, that is F, is given by 1 upon 4 pi epsilon naught Q1, and in Q1 we have capital Q, and Q2, that is we have a small q, divided by distance between these two charges. And this test charge could be anything. If we have different test charges, then accordingly value of force will be different. So we define a quantity, that is F by Q, and this Q is our test charge. When force is divided by test charge, what we get is 1 upon 4 pi epsilon naught capital Q by R square, and this quantity is known as electric field. So we have a mathematical equation or formula of electric field. What it says, that at some distance r from the source charge, there exists a field or electric field inside which another charge can feel the force of attraction or repulsion. This field is inversely proportional to the square of the distance. That is, if we move away from the source charge, then this force will get smaller and smaller, and if we come closer to the source charge, then this force will become larger and larger. And as the force is a vector, in the same way electric field is also a vector quantity, and direction of